In this lesson, I'll show you how to use the distance formula to solve problems. Question 1 reads, to make round parts, programmable machine tools often use a coordinate system with the origin at the center of the part. Take a look. Our part is right here, and the origin is at the center. How far apart are the centers of the mounting holes A and B, shown right here, in this cam? The coordinates are in centimeters, and round your answer to the nearest tenth. Let's go ahead and figure this out. We want to know the distance between A and B. We first have to write down the coordinates of A and B. Take a look at A. It has the coordinates -3 for its x-axis and +5 for its y. So A is -3 and +5. You always write down x and then y. The coordinates for B are 2 and -4. The distance formula, or in other words, the formula for the length of a line segment, looks like this, where D is equal to x2 minus x1 squared plus y2 minus y1 squared, all square rooted. Now that we've written down the formula, let's call this point 1 and point 2. And the reason why I'm calling it point 1 and point 2 is so that I can easily identify what x1, y1, x2, and y2 are. So I'm going to call this x1 because it's 1, and this coordinate y1, this is x2, y2. Now all I have to do is plug and play. So x2 is 2 minus -3. All of that is being squared, plus y2 is equal to -4 minus 5, all raised to the power of 2, and all of this is being square rooted. Using our calculator, we have 2 minus -3, which is 2 plus 3. 5 to the power of 2 is 25. So I'll write down 25 plus -4 minus 5 is equal to -9 to the power of 2 is 81. Now we square root, and we end up with approximately 10.29. Now they want it to the nearest tenth, and since this 2 is followed by a 9, I'll raise this 2 up to 10.3. 10.3 is the distance in centimeters from point A to point B in this cam. The next question reads, an air ambulance service uses a grid system to help estimate flying times and fuel requirements. Coordinates on this grid are distances in kilometers east and north of a reference point at the lower left corner of a map of northern Ontario. A helicopter ambulance picks up a patient at point P, which has the coordinates 96 and 197. The nearest hospitals that can provide the treatment the patient needs are in Timmins at the coordinates 200 and 296, and Sudbury at the coordinates 232 and 80. To which hospital should the helicopter take the patient? So technically we are at the coordinates 96 and 197, and to give you a better visual of what this looks like, take a look at an XY plane that plots these 3 points. We have a hospital here and a hospital here, and we're right here. To find the answer to the best possible hospital to take this patient, we have to find the distance from point P to T and the distance from point P to S, and then compare which one is shorter. Let's go ahead and do that. We'll call this 1 and 2. Therefore, our formula will be distance is equal to x2 minus x1. We have 200 minus 96 being squared, plus y2 minus y1, 296 minus 197, and all of this is being square rooted. Before I find the answer to this, I also want to set up the next one. So we want to find the distance from P to S. I'll call this point 2. And what I like to do is read the graph just like how I would read a book from left to right. So since this point is closest to the left, I'll call this point 1 and point 2. So my second distance for PS will equal to 232 minus 96 squared plus the difference in y's, 80 minus 197, and this is being square rooted. Let's use our calculator for the first and for the second. Let's start with the first, and I'll try to do this all in one step. So we have the square root bracket 200 minus 96 to the power of 2 plus bracket 296 minus 197 raised to the power of 2. That's a distance of 143. Each of these units represents a kilometer, so that's 143 kilometers approximately. Let's do the same thing for the other one. Let's start off with the square root of 232 minus 96 raised to the power of 2 plus bracket 80 minus 197 raised to the power of 2, and we end up with 179. So it's best that the helicopter go to the hospital in Timmins because it's a shorter distance of 143. And so there you have it. 2 examples on how to use the distance formula to solve problems.